guys, it's Miss Miklos, and in this lecture we are talking about solving linear inequalities. So I just want to start with a few reminders. Okay, the first is just to recall that whenever we multiply or divide by a negative number, we must reverse the inequality symbol. Okay, so that's just something important to remember as we are isolating the variables in our inequalities. Back in Algebra 1, whenever you guys went ahead and graphed these inequalities, whenever we had less than or greater than, you guys used an open circle on your number line. Likewise, when it said less than or equal to or greater than or equal to, you used a closed circle. We're going to do something a little bit different in Algebra 2, and this is really going to prepare us for next chapter when we talk about domain and functions, and this will really prepare you guys for pre-calculus next year. This year we're going to use something that is called interval notation. And this time, whenever we happen to have an open circle, we're going to use parentheses. Okay, so the parentheses is going to be based on whatever direction we're shading in. So instead of putting an open circle, we're going to be using parentheses. Parenthesis basically means that that value is not included in our set of answers. Whenever we have an equals, instead of using a closed circle, we're going to go ahead and use a bracket to show that. Okay, a bracket means that that value is included in our final answer. So basically we have not included or open circles. We're going to be using parentheses this year. When we would have been using closed circle, we are going to go ahead and use brackets. So that's really the new thing for us to know. Another thing that you guys probably learned back in Algebra 1 is that when it's less than, shade to the left, and when it's greater than, shade to the right. And I just want to stress to you guys that that is only when the variable is on the left side of the inequality. Okay, so for example, if we had something like all real numbers greater than 2, notice I didn't say x greater than 2, I called that all real numbers. I need to think where are numbers that are greater than 2, and that would be to the right. However, if it had been written like, let's say this, okay, sometimes we read this in the wrong way and we would go, oh, it's a less than sign, I need to shade to the left. But whenever we read an inequality, we always start from the variable. Okay, so if the open side, you guys may have learned it was an alligator or a Pac-Man, it's eating the bigger number, okay? We're always going to read from the variable. So this one's easy, all numbers greater than 2. This one actually says the exact same thing because it's all real numbers, and then since it's open, it would be greater than 2. So let's go ahead and get straight into our problems. So our directions ask us to solve and then graph on a number line. And these are the types of questions that you guys will see on a quiz or a test. So when I am solving this, I'm going to start by isolating my variable, and I'm going to do that in a way very similar to how we did that with equations. So I'm going to add 8 to both sides. So I get 5y is less than 20. Then I would divide by 5. So I get all numbers that are less than 4. So on my homework, what I would be doing, I have all numbers less than 4. Okay, here's 4. And I need to figure out where would those values be? Where are numbers that are less than 4? Well, they are to the left. I need to think, is 4 included in my answer? And that would be no, because I do not see less than or equal to. So that means I'm going to use a parenthesis and I'm going to shade to the left. And basically all a number line is doing, it's a visual representation of what our solutions are. Now, if I was going to go ahead and write this in interval notation, and I want to just kind of pause and show you guys. If you did all of this, you guys would get full credit on a quiz or a test, okay? Notice I do need to have this parenthesis and not an open circle to show me you understand that. But since this is Honors Algebra 2, we're going to go above and beyond here. And we're going to go ahead and write this in interval notation. And as I said, on a quiz or test, you're not going to have to do this. On the homework, you don't have to do this, but I want to show it to us because that's where the parentheses and brackets come from. And next chapter, when we talk about functions, we will have to use interval notation. So when I read a number line, I always start from the left. So as I travel, I notice that everything over here is shaded. So I need to think, what's the smallest number that's shaded? And the smallest number in the world is negative infinity. Now with negative infinity, I'm using a parenthesis here, and the reason is infinity is a theoretical number that we never actually reach. So this is basically telling me that it's getting really close to negative infinity. It's going to all those small numbers, but it's never we never actually get to infinity. Okay, so as I'm coming along here, I notice that my shading stops here at 4, and I notice that I used a parenthesis, so I'm going to say 4 parenthesis. So in pre-calc, this is what you guys would give me as your answer. A lot of the times we wouldn't even graph it. But this is telling me all the solutions are from negative infinity to 4. Okay, so now that we've gone through one, we're going to see that the rest of these are pretty similar. So in solving here, I always like to have my variable on the left-hand side just because for me it makes it easier to know where I am going to be shading. So I'm going to subtract 6x from both sides. So I get negative 4x plus 1 is less than or equal to negative 1. Then I'm going to subtract 1, so negative 4x is less than or equal to negative 2. I'm going to divide by negative 4, and as soon as I see that I'm dividing by this negative, I know that I need to flip my inequality and reduce negative 2 over negative 4 to 1/2. Okay, so here's 1/2. I need to figure out, should I use a parenthesis or a bracket? Since it says equal to, my answers are all real numbers greater than or equal to 1/2. I know the equal to tells me I need a bracket. Values that are greater than 1/2 are going to be to the right. So I would go ahead and draw a bracket and shade everything to the right. So if I was writing this in interval notation, as I start from the left, I notice nothing's going on until I hit 1/2. 1/2 has a bracket on it, so I'm going to use a bracket in my interval notation. And then all the solutions from 1/2 until all the way over here to positive infinity are solutions. So I'm going to say I'm going to say 1/2 to infinity. Just a reminder, this bracket means 1/2 is included in our solution set. Number 3, we have a word problem here, and I wanted to do one of these with you guys because sometimes it can be a little confusing. So it says the weight W in pounds of a certain fish is given by the equation y equals 10.4 t minus 2.2, where t is the age of the fish in years. Describe the age of a group of these fish in which no fish weighs more than 29 pounds. And the first thing that I'm going to do here is I'm just going to go ahead and highlight the more than 29 pounds, okay? Because to me, that is really helping us figure out what inequality symbol we're going to use. And it's also telling me 29 pounds is the weight. So I'm going to substitute 29 in for W. And then I'm going to go ahead and write the other side. And I'm just going to think for a second, okay? If this is the weight and this is the actual fish, is it okay if these fish weigh more than 29 pounds? And it's not, because it says no fish weighs more than 29 pounds. Okay, so I know that the inequality cannot be opening up to the weight of the fish here. It can be equal because 29 pounds is not more than 29 pounds, and it can be less than 29 pounds as well. So now I'm going to go ahead and isolate t. So I'm going to add 2.2, and I get 31.2 2 is greater than or equal to 10.4t. When I divide by 10.4, I get 3 is greater than or equal to t. So the way that I would actually read this is that no fish, I'm going to say fish can be 3 years old or younger. Okay, because this is telling me all fish that are less than or equal to 3, and I know that t represents their age. So when we have an inequality word problem, we just need to put a little bit of thought into it. Now let's go ahead and get into some harder ones. So with our compound inequalities, we have and problems or problems. With and problems, the key thing here is that our answers must be solutions to both of the inequalities. With or problems, our solutions only need to work for one of them. Okay, so an example here, it says x is greater than or equal to -2 and x is less than or equal to 1. Those solutions must be greater than or equal to -2 and less than 1. So it needs to fit both characteristics. And a common mistake is that some of you might just think, oh, well, in Algebra 1, whenever it was and, we just shaded in between. And while often we will shade in between, that is not always true in this class. And we will see that in our notes today. Or it says x is less than -1 or x is greater than or equal to 2. This is like doing two problems on the same sheet of paper on the same exact number line. Once again, you guys may have learned, oh, when it's an or, it's always on the outsides, and that's not always true. It happens a lot, but it's not going to be true all the time. So let's get straight into this here. So it says solve and graph on a number line. So I'm going to go ahead and split this up to be -2 is less than or equal to 3x minus 8. And, because I know this is an and problem because it doesn't say or. Okay, or problems always say or. So I'm going to have to solve both of these independently. So I'm going to add 8. So I get 6 is less than or equal to 3x. So when I divide by 3, I get x, or all numbers that are greater than or equal to 2. Okay, my other one here, I'm going to go ahead and add 8. When I divide by 3, I get all numbers that are less than or equal to 6. So at this point, what I'm going to do is I'm actually going to graph these above the number line. So I'm not actually going to put my answer on here yet. I'm going to do a little sketch. And I need to look and see, where do they overlap? Okay, because the sections where they overlap is going to contain the values that are true for both of the sets of inequalities. And then on my number line, I'm just going to shade where the overlap is. So let's do this. All values that are greater than or equal to 2. Here's 2. Okay, here's 6. Oh, I didn't mention this before, but I think in Honors Algebra 2, we have a pretty good understanding of where numbers are at on the number line. So whenever we do number lines, you guys don't need to like write 0 or write out all these things. We can just put the important points down, and that's totally fine. Okay, so numbers that are greater than or equal to 2, I'm going to use a bracket because it has this equals. And I know that those are going to go to the right because that's where bigger values are. Notice it goes all the way, it goes past 6 because numbers like 7, 8, 9, 10, all these values over here are greater than 2. Okay, my second piece, it says x is less than or equal to 6. So all real numbers that are less than or equal to 6, I'm using a bracket again because it does say equal to, and values that are less than 6 would go to the left. Now looking at this, I notice that it overlaps in this middle section. In fact, I'm going to go ahead and just kind of highlight that for us. So on my actual number line here, I'm going to put, oh, I did not mean to do that. Let's undo that. I'm going to go ahead and put brackets. And the reason why is because I used bracket here and here. And this is where the overlap happened. So I'm going to shade everything in between. Okay, if we were going to write this in interval notation, I would say 2 to 6 is our solution set, and that would include 2 and include 6. Number 2, we have an OR problem. So when we have an OR problem, I'm just going to do these separately. So I'm subtracting 3 that I'm going to divide by 2, so I get numbers that are less than 1. My other inequality, I'm going to add 7, so I'll write that there. So I get 4x is greater than 16. When I divide by 4, I get x is greater than 4. Okay, so all numbers that are less than 1, and let me put 1 and 4 on my number line. Numbers that are less than 1, I'm using a parenthesis because it does not have an equal to, and numbers that are less than 1 are to the left. Notice I'm shading straight on the number line here. It does not need to fit both inequalities. If it works for one, we're good. X is greater than 4. Where are all numbers that are greater than 4? That would be a parenthesis again, and numbers greater than 4 would be to the right. So this time, if I was writing this in interval notation, I noticed this one's very different because my answers are in 2 different spots. Okay, so I'm going to start, this first piece would go from negative infinity to 1, and then I have a break, and I start up again at 4 to infinity. Now to connect these, we're going to use a symbol. It looks like a U kind of, and we call this union, and basically union means and. So it's just telling me that it's from negative infinity to 1 and 4 to infinity. So I think at this point we're probably pretty good at solving the inequalities. I just want to practice a few more of these because I'm letting you know this section tends to be one where students make mistakes on the test because they rush through it. Okay, so let's just go through these problems. We have 4 more, but the nice thing is that x is already isolated. Okay, number 6, I have an OR problem, so I can just go straight on the number line. I notice my 2 important numbers here are 0 and 4. So I have to think, where are numbers that are less than 0? So that would be a parenthesis and to the left. Parenthesis once again because it just says less than. I did not have less than or equal to. Where are values that are greater than or equal to 4? So I'm going to use a bracket because it does say equal to, and values greater than 4 would be to the right. So if I'm writing this in interval notation, it would be negative infinity to 0, union 4 to positive infinity. Number 7, this time, 0 and 4 are the important numbers again, except we have an and problem, so that means I'm going to do things above. So it says x is less than 0. So where are numbers that are less than 0? That would be to the left. And x is greater than 4. So where are values that are greater than 4? That would be to the right. So looking at this, where is my overlap? And I realized that there isn't one. Okay, and if we think about it, that would make sense because there are no numbers that exist that are less than 0 and greater than 4. So the way that we write that is no solution. No solution, we often use the null set to denote that. For interval notation here, we wouldn't write anything in interval notation. No solution would just be our answer. Okay, number 8, we have another and problem. Okay, here's 0 and 4. So it says numbers that are greater than 0. So that would be to the right, and I'm using a parenthesis. And numbers that are greater than or equal to 4. So that would also be to the right, and this time I'm using a bracket. So where do these overlap? And we notice they overlap everything to the right. So that means that on my actual number line, at 4 is where things begin. And 4, we had a bracket, and I'm going to shade everything to the right side. A good way to double check if we did this correctly is we could choose a number over here, like let's try 3. Is 3 greater than 0? Yes. And is 3 greater than or equal to 4? No, it's not. So since we answered no to one of those, that's why it's not shaded. Things over here like 5 is greater than 0 and 5 is greater than or equal to 4. So if I was writing this in interval notation, since I only shaded in one section, that means I don't need to use a union. So my answer would be from 4 to infinity. Final question. Once again, we have 0 and 4. This time I have an or problem, so I'm going to graph right away. So it says all values that are less than 4. So I have a parenthesis, and I'm going to shade to the left of 4, and I'm shading all the way to the end, okay, because values over here are less than 4. My other one says values that are greater than 0. So I'm using a parenthesis, values that are greater to the right, and I'm going to go all the way to the end because values that are like 5 or 6 are greater than 0 as well. Okay, I want to point out, if this had been an and problem, where would we have shaded? Well, we would have seen that it overlaps in the middle, so that would have been our only solution. Here, though, since it was or, we shaded everything. So there's 2 ways you guys could write this. We could use the script R, which denotes all real numbers. If we were writing this in interval notation, I only shaded in one area. So the smallest value is negative infinity, and the biggest value is positive infinity. So really the only new thing we talked about today from what you guys learned back in Algebra 2 is this concept of interval notation. So just a reminder, double check that we're using parentheses and brackets instead of open and closed circles.